Hi, Chris Kuzmal here working on counting sort. We've already completed the histogram and scan methods. Now we're going to do the third and final helper method, which I don't have a great name for. I'm thinking of just calling it placement, and we'll call this placement test here in the code, placement test 1. And of course that means we need to implement it. And so placement test 1, I'm feeling a little excessively ambitious about this, so we'll see whether or not I get into trouble. We are going to have an array which is to be sorted, and it's going to be the same array as we've had all along, in a sense. If we look at the histogram test, we see AR3141. Our ultimate goal is to put this in the order 1, 1, 3, 4. And so we'll go ahead and start off with an array just like that. That is 3, 1, 4, 1, not 1, 1, 3, 4, not yet. Okay. And we are all going to also assume that we have been given the histogram result, the expected result from having done, I'm sorry, not the histogram, but actually the scan. So 0, 2, 3, 4, what we have here from the scan test. Okay. And this is actually the expected scan output. All right. At a later time, we should write a code that actually receives the expected scan output or produces the expected scan output. But we're going to separate our testing here so that the placement test only tests the behavior after the other code has supposedly worked. All right, now it's complaining that we have not completed it yet. We're going to have our expected placement output, and that's going to be the sorted array, which is going to be 1, 1, 3, 4. And later on, we're going to actually have what we call satellite data that will attach to the array, but we're not going to do that yet. That's the thing. I was going to be ambitious and have satellite data, but I hope and I think wisely selected to not do that. We're just going to go from AR and from what's on line 11 and line 12 in order to produce what's on line 13. And so we invoke we have an actual, okay, and that's going to be the result of invoking placement, and placement's going to receive the expected, it's going to receive AR and expected scan output. And what it should do is it should produce our desired expected placement output. Okay, and so we now get to use the exact same code as we've been using. In this case, for example, lines 23 through 27. And I don't know what this print line is doing inside of scan test. That concerns me, actually. Why is that there? We'll have to go along and fix that up. Because we're going to increment, pass, and fail, but we're not going to do anything else in terms of printing. Now, of course, there's one difference here, and this is we have expected placement output. I'm going to go ahead and revert that to expected. Okay, and we're hoping that it'll be implicitly obvious that placement is the expected value for placement is well expected. And that will make it so that this code, lines 15 through 19, is identical to all the other code. And I think, like I have said in the past, if we become clever, we'll find a way to encapsulate. It might be the case that this code that I've highlighted here should be what we call a macro, and we might learn about macros later on. But we'll take our time on developing good software strategies as long as we're reasonably coherent. Now, placement tests should work in a lovely way, except for one problem that it should have, which is that we have not implemented the placement method. But let's see if we run and get the expected failure, which is the method placement has not been defined, and that's exactly the error we get. So we now just need to implement public static. Is this going to be void? It's not. Placement returns a value. Okay. And placement receives two things. One is going to be an integer array of the to be sorted. We'll just call it A. And an integer array of the expected scan, the scan output, which I don't know what to call it. In Common License and Revest, to give it a ridiculous name like B or C or something like that. And I'm going to call it address, and I'm hoping that that name will work out because it's kind of the address. It kind of tells us what is the location that we're going to be placing the data. It's an A into our output, and our output is going to be an array called retval, which is going to be a new integer array, and it's going to be the same size as A. All right, and ultimately we will return retval. But of course, for now, placement is just a stub, and our hope for this video is just to have established what the behavior of placement is for an example. And it does indeed fail, although we see that our printout is not like we wanted. We have passed one fail. We see passed and failed being printed out twice because the pass and fail printout line is inside scan test. So we're going to move that up to be after the placement test in main, which is where it really belongs. And so this should boil down to 2 passes and 1 fails. We still have things getting printed out. Actually, that's sort of interesting. I don't know why. Oh, the expected and failed, although the passed 1 fail 0 is a little bit of a surprise. I guess maybe we have more pass fail code in histogram test 1. Yes, so somehow or other I accidentally put that pass fail code inside of the tests rather than inside of the main. And so now this is better. We have this expected failure with the expected and actual, and that's in fact what we were expecting. We were expecting this failure to do what was expected, because our stub produces an array of 4 zeros. Okay, we still haven't done a thing that I would like to do would be to at least kind of in our testing give ourselves credit for having gotten the right size array, but I haven't done that, and I'm going to just live with what we have now because we're approaching 10 minutes and this is good.